Hey, South Carolina's math industry, and we are going to take a look at the electromagnativity. So, what we're going to do is, the first thing we got to understand is what this is. So, right here, this is going to be called the atomic radius. So, these two red circles are supposed to look like two atoms that are bonded together. And it's telling you how can we do the math in terms of measuring the atomic radius. Just like circles and just like spheres, atoms are made of small, round-shaped spheres. And what that is saying is the atomic radius is going to be from the edge of the atom to the middle of the atom. Sort of something like here's a circle, and the radius is from the middle to the edge of the circle. That is for the math part, but for chemistry, it's called the atomic radius. The other thing is, when two atoms are bonded together, we also have to measure the distance between the nuclei, and it's literally called the distance between the nuclei. It's not really a name, but the nuclei are the middle parts of the atom. And when they're meshed together, we can also measure them too. Just so you know, the atomic radius is going to be 1/2 the size of the distance between the nuclei. Just like in mathematics, the radius is going to be 1/2 exactly the size of the diameter of the circle. But did you know that when we use electromagnetivity, the thing is, some of the atoms have different strengths. But to understand the strengths of this kind of atom, the thing is, picture the nucleus is the largest thing of the atom. And we also said that the electrons are sort of like those planets going around the nuclei, just like the planets going around the sun. Right here is going to be the strongest force. Right over here is going to be the weakest force. So as you move towards the atom, the center of it, and get close to the nuclei, the force between the electrons and the nuclei are going to get stronger and stronger and stronger. But as you move farther out, the problem is the strength between the electron going around the thing and keeping it in place gets weaker. And that's why the outermost layer electrons are usually traded to go into a totally different atom. These electrons are going to be called valence electrons. So the valence electrons usually get traded off to join another atom in place of it. Now it becomes another charge. So here's another thing. Earlier we said that some of these atoms have different kinds of charges, but also these atoms have different strengths and weaknesses. Depending on the size of the atom itself, some may be weaker, some may be stronger. Here's an example. See how we have this right here? We're going to say it's a hydrogen atom. The thing is, this hydrogen atom is very weak. Naturally, it can only hold one electron. The reason why it can't hold more than one naturally is because it's too weak to actually have that pull to actually hold enough of those electrons together. Just like this one's more powerful because at a stable level, it can hold more electrons. The other thing is, the atom is usually bigger and its atomic radius is a lot bigger. Hydrogen, not so much. So what the whole point of this video is saying that electromagnetivity measures the atomic radius of the atom, the charge of the atom, and also how atoms will attract electrons.